These are the test example questions for target 6, which is on graphing quadratic equations. And you should be able to do that regardless of which form it is. So the key points that you can pick from this one, which is vertex form, are the vertex, which is the HK. And it's real handy that this is already a minus, so the H is positive 1, the K is positive 4. You can also tell that this one opens up, or excuse me, down. And you can tell that because the A value is negative. Now, as far as the intercepts go, the x-intercepts are not super convenient to find. The y-intercept isn't too bad of a point to find because the y-intercept is the y value when x is 0. Oops. So what I'm going to do is I'm going to put 0 into the equation for x and calculate that. Doing order of operations, parentheses first, then squaring, so negative 1 squared is 1, then multiply by negative 2 to get negative 2, and then adding the 4 to get positive 2. I'm going to jump ahead to the graph of that one while we're on that one. So to graph this, for sure you need the vertex, and you need at least 1 point on each side of the vertex. So my vertex is 1, 4. So I go over 1, up 4, and I put a point. And my y-intercept was 0, 2. Now, I can graph this because I know there's going to be symmetry across the vertical line through the vertex. That axis of symmetry, as it's called, is the vertical line with equation x equals 1. So if I look at this y-intercept point, it's 1 unit to the left of that line. So if I go 1 unit the other side of that line, I'll have another point. Another way you can kind of go from the vertex to these points is you can use this as a guide. From the vertex, you're going to go over 1 and down 2 to the next point. Now, if I want to get some more detail there, I might put in another point like, let's put in negative 1. So when I put in negative 1 in for the x, I'd get negative 2 squared, which is 4, times negative 2, which is negative 8, plus 4, which is negative 4. So if I plot that point, negative 1, negative 4, and then I can go symmetric the other side, 2 units to the right. Now I'm starting to see that it's a pretty narrow upside down parabola. And when you draw it, make sure you put arrows at the end to indicate that it continues to go down and out. So if I go to number 2, or letter B, I should say. Letter B is in intercept form. So from intercept form, we can easily see the x-intercepts. They are the values that make the function 0, or each factor 0. So positive 3 would make that factor 0, negative 5 would make that factor 0. I can also see that it's going to open up because this is positive. And then I need to be able to find the vertex. You have to have the vertex to do the graph. So to get the vertex, I'm going to add the x-intercepts together and divide by 2. So the x-coordinate is negative 1. And then if I put negative 1 in place of the 2 x's, I'll get my y-coordinate of the vertex. So it would be 4 times negative 4 times positive 4. So that's 4 times 4 times 4 is 64, and negative times 2 positives is a negative. So now I designed this kind of poorly because you're going to have a tough time graphing that one. Okay, it's going to be -1, -64. So let's kind of see how that looks with the intercepts. So we have 3 and -5 are the x-intercepts. So +3 and -5 are the x-intercepts. My axis of symmetry is going to be right in the middle at -1. I can't fit the vertex on this scale because the scale is by ones. It only goes as low as -10. So I'm just going to get at least a couple other points for my table. And if I put 0 in here for the x's, that's an easy one to get. I'd have 4 times -3 times 5. Unfortunately, that's -60, and I can't fit that point on there either. So what I'm going to do is I'm just going to go to points near the x-intercept. So let's try like 4, or let's go in between. Let's try 3. No, 2 in. 1 unit to the left of that one. So if I put 2 in here, I get 4 times -1 times 7. So that's 4 times -1 times 7. That's still off the chart. So what that tells me is this parabola, that's not even really accurate. It's going to be really steep down here, but it's going to come to a vertex way down here somewhere. Let's see if I can get a point to the right of that. So let's try 4. If I put 4 in here, I'd get 9 times 1 times 4, which is 36. So I can't fit that one either. Okay, I'm really kind of out of luck to graph this. What I should probably do is change my scale to be something like, let's see, the vertex was -64. So maybe I'd make each of these worth like 5 or something. Or no, I need more than that. I'll just make each of these worth 10. So here's -10, 20, 30, 40, 50, 64. So my vertex would be somewhere right around here. And I could keep the same y coordinates, or x coordinates. So this is the point 3, 0, -5, 0, and this is my vertex, -1, -64. And there's my at least 3 precise points to draw the parabola. If you want to be more accurate, you can get more. Lastly, C, we have a standard form one. So I'm going to do the -b/2a idea. There's no number there, it's a 1. So it would be -1/2 times -3. So that would be a negative over a negative is a positive, 1/6. That's my vertex. And then I could get the y coordinate of my vertex by plugging that in. And again, this is not going to be one that's real convenient to graph. So that's why in your table or in your work, I want you to show some of those exact points. So I've got -3 times 1/6 squared plus 1/6 plus 2. And if I wanted that as a fraction, it would be 25/12, which is 2 1/12. So it's a little over 2. Now the other easy point from standard form is the y-intercept. If you plug 0 in for the x's, you'll get 0 plus 2 equals y. So the y coordinate is 2. So now I'm going to do my very best to plot those. 1/6, comma 2 and 1/12. That's my vertex. So 1/6 to the right of the origin, up 2 and a little over. It's going to be like kind of right in there. And then my y-intercept was right at 2. I could use symmetry, but that's not going to be real great. So I'm just going to get a few more points here by picking some numbers. The symmetry is going to be tougher to get points in pairs like it was before. So I'd have -3 plus 3, that one's 0. So that's a good point to have. That's an x-intercept. When you put 1 in, you get 0. Let's try to get a point further on the other side. How about like -2? So if I put -2's in there, I'm going to get 4 times -2, which is -12. That one's going to be off the chart. Let's try -1. So -1 squared is 1 times -3 is -3. Minus 1 is -4, plus 2 is -2. So when you put -1 in, you get -2. So now I've got at least a few points that I can grab. And then finally, number 2 is just convert part A into standard form. So that would again be part of the basic level. The meets level would be actually doing the graph. There aren't any exceed level on this one because I think there was enough exceeds with the target 5 completing the square. So to get this in standard form, you have to think of x minus 1, the quantity squared, as x minus 1 times itself. If you want, you could multiply that out with a box, or you could use the distributive property twice, whichever is your preferred method. So you get x squared minus 1x plus 1. So I'd have -2 times x squared minus 2x plus 1. Because the 2 minus 1x make the minus 2x. And then I distribute the -2. I've got -2 times x squared. -2 times a -2x is a positive 4x. -2 times 1 is a -2. And then lastly, combine your like terms. So there's your equation in standard form. If you did the -b over 2a for that, you get -1, which is the x-coordinate of the vertex. So that just kind of double checks that. Because remember, this is equivalent to the original, it just looks different. Any questions on that one? Yeah, Parker.
On number 3, I was just confused on, or C, I was confused on how you get 25 over 12.